Your first page of homework will be to complete the atomic radius page on page 66. Each of these numbers at the peaks are from your alkali metals. Notice 3, 11, 19, 37, 55. It's very important that you are capable of reading a graph, analyzing it, and integrating it to what you already know about atomic radius. So as you read the top, you need to read, highlight, make notes, and then on the bottom you'll be answering these questions. So electronegativity and ions. We've learned about ions. We know that atoms become ions by gaining or losing electrons. We know their charges based off of the periodic table and what family they're in. And we know that electronegativity is the ability to attract or steal an electron. So now let's integrate all that. If electronegativity is the ability to attract or steal an electron, that's how ions are created. How the atoms gain or lose electrons is because another atom has a high electronegativity and can steal it. So electronegativity is the basis for bonding. It's the process that forms compounds and molecules and thereby forms you. You are not just a pile of elements. You don't have one pinky of sulfur and another finger of carbon. You are made up of all kinds of compounds that made up your cells that made up you. Compounds are kind of crucial for our existence. And electronegativity is going to be the basis for why compounds are made. Remember that all matter is made up of atoms of elements, but rarely do we find elements in their pure form. So we went through our periodic table and labeled solids, liquids, and gases. We rarely find them like that in their pure form. Instead, we find them in compounds. So for instance, table salt is made up of two elements, sodium and chlorine. How they come to be bonded is from their differences in electronegativity. They are bonded because of their differences in electronegativity. So in order to compare their electronegativities on page 15, which is also page 65 in your workbook, there's the table of electronegativities which has the electronegativity number for each element. Flip there now. What is the electronegativity of sodium? 0.9. And what is the electronegativity of chlorine? 3. Which makes my difference of electronegativity 2.1. Is the difference greater than 1.7? Yes. So real quickly, let's go over our notes about electronegativity. Electronegativity was the ability of an atom to attract or steal an electron from another atom. So when atoms interact, they each have their own electronegativity. The atom with the higher electronegativity is going to pull on the electrons of the atom with the lower electronegativity. Atoms with higher electronegativity are going to pull on the electrons of atoms with lower electronegativity. So we have a 1.7 rule when we're looking at these differences in electronegativity. If the difference in electronegativity between two atoms is greater than 1.7, the atom with the higher electronegativity is able to steal one or more electrons. Thus, ions are formed. The atom with the higher electronegativity gains one or more electrons. If I gain electrons, I become an anion. And anions have a negative charge because they've gained more negatives than they have positives. The atom with the lower electronegativity is going to lose electrons, becoming a cation. Since I have lost electrons, I now have more protons than electrons, and I have a positive charge. Positives and negatives are attracted. We know that. Therefore, the new positive and negative ions stick together once the electrons have been transferred. The new positive and negative ions stick together once the electrons have been transferred. So it's the electronegativity that creates the transfer of electrons. The high electronegative one steals an electron from the low electronegative one. And then the one who stole one becomes negative, the one who lost one becomes positive, and now they can't separate from each other. Now we have a positive and a negative right beside one another, and they're stuck together. That is the bond. This positive and negative attraction holding them together is called an ionic bond. Highlight that in a couple colors. This is very crucial you understand this concept. The positive and negative attraction holding them together is what is called an ionic bond. You're going to come back and answer these two questions for homework. And then let's continue on to defining an ionic bond. Ionic bonds are the bonds formed between two ions once they have transferred electrons, becoming anions and cations. They are the bonds formed between two ions once they have transferred electrons, becoming anions and cations. Since elements have different electronegativity, they can bond with other elements. These chemical bonds are an attempt to fill electron shells. The high electronegativity element is going to steal electrons until it has a full outer shell. Then it can't steal any more electrons. Now metals have few electrons in their outer shell and have a low electronegativity. Therefore, they easily give up electrons, becoming cations. Nonmetals have many electrons in their outer shell and have high electronegativity. Therefore, they can easily take electrons, becoming anions, a negative ion. This difference between metals and nonmetals is what creates our ionic bonds. So some of the properties of ionic bonds is they are between metals and nonmetals. These elements have very different electronegativities. Metals have low electronegativity, nonmetals have high. The bond forms by transferring electrons. Once the electrons are transferred, that positive and negative are attracted to one another and they are bonded together. And they are high conductors with high melting points. They easily conduct electricity, they easily conduct heat, and they have high melting points.